in Bangalore. So today I am going to demonstrate on ECG. That's the basic and fundamentals of ECG. See, in order to understand the basic and fundamental concepts of ECG, it's going to take 3 to 4 hours or 5 to 6 classes. But here we don't have time, so I will try my best in order to give the brief overview and basic concepts and fundamentals of ECG. So in order to understand the ECG, I have formulated the outline. So first we will discuss about the electrophysiology of heart. Secondly, we will discuss there are some rules which are very critical to understand the ECG that we will discuss. And thirdly, cardiac factors. Then cardiac factors to ECG. How the cardiac factors are generated in the heart and how these cardiac factors translate into the ECG pattern. So first is electrophysiology of heart. In that first I will see the conduction system of heart. See, this is our heart. The conduction system of heart consists of AC node, AV node, bundle of his, and Purkinje fibers. Purkinje fibers. See, the AC node, it is an specialized myocardial tissue which is having the property of auto-religiously, which can generate the electrical signals. So this AC node, it will generate the electrical signals when depolarization is required. So it will generate the electrical signals, and these signals it will separate throughout the atrium. When these electrical signals reach on the septum, see, this septum is called fibrous annulus. And this septum, it is electrically insulated. So when these electrical signals reach to fibrous annulus, these electrical signals will die out. The only pathway or the gateway to reach the electrical signals from the SA node to ventricle is AV node. So when these electrical signals reach AV node, then it will transmit via bundle of his, then Purkinje fibers. Okay? So this is the conduction system of the heart. See, we can categorize the heart into 3 parts based upon the conductivity pattern. Okay, so first is first conductor and which can generate strong electrical activity. Fast and strong electrical activity. Okay, this is the first one. In this, ventricle will come. Ventricle and because ventricle is a bigger tissue. Okay, and it's a fast conductor. How it is fast conductor? There is a detailed physiology behind this that I'm not going to explain. So you just remember the fast and stronger electric current of the heart is ventricle. Okay. Second one is atria. See, atria is you can say it's a mild conductor. Means it transmits electrical current slowly as compared to ventricle. It's going to generate not that much current as compared to ventricle because the size of atria is less. So it is the mild. And third one is minimal. Minimal, it is AV node. AV node is a very slow conductor of electrical signals. even when we apply the ECG machine on the AV node, ECG machine is not going to detect any electrical signals passing through the AV node. Okay, so first is ventricles are first, then atria, then AV node. Okay, now we will look the action potential. How the action potential is generated in the heart, because this action potential is a very important and very critical in order to understand the ECG. Okay, so now action potential. See, this is heart, the cross section of the mitochondria, and we will zoom 3 cells. How many cells we will zoom? 3 cells, like this. This is one cell. Okay, and this is another cell. Okay, and this is another cell. Okay, 3 cells. See, this is the extracellular space, and this is the intracellular space. On the surface of the mitochondrial cells, there are channels. This is the sodium channel. This is the potassium channel. This is the calcium channel. Okay, this is the calcium channel. See, the resting membrane potential of the heart is minus 90 millielectric volt. Okay, this is the minus 90 millivolt. Okay, resting membrane potential of the heart. When there is appropriate stimulus from the SC node, this is the stimulus from the SC node. When there is appropriate stimulus from the SC node, it is going to cause the influx of sodium. Influx of sodium. See, the sodium, it contains positive charge. When there is influx of sodium, negativity, because this is the negative charge here. Okay, this is okay. Resting membrane potential is minus 90 millielectric volt. So when there is influx of positive charge, there will be decrease of negativity. Okay, so eventually it will rise up to minus 70 millielectric volt. Minus 70 millielectric volt is a threshold potential. So what is threshold potential? Threshold potential is a potential which causes the rush of sodium influx, which causes rapid stimulation of sodium channel, and there is the rush of sodium influx. When is the influx of sodium, see, negativity, it will tend to decrease because the positive ions are coming inside. Okay, so it will form the depolarization is going to happen. Okay, it will eventually reach up to plus 10. When it will reach up to plus 10, then this channel it is stimulated because it's a voltage gated channel. Okay, so voltage gated channel. Okay, see, when this calcium is stimulated, also potassium channel is stimulated, but there is efflux of potassium and influx of potassium. Efflux of potassium and influx of calcium. Okay, see, if we see the sodium channel is first, then calcium generally, then potassium, but the efflux of potassium is more rapid than the influx of calcium. So there is a rapid influx of potassium and slow influx of calcium. So when there is the influx of potassium, because it contains positive charge, so charge will tend to decrease. But there is also efflux of calcium, so it contains plus 2 positive charge. At some time, the charge it will, because there is efflux also, there is influx also. There is no net gain or loss of charge. So it will have the isoelectrical phase. That's called Plateau phase. And because this is the false channel, when it will gain to negative polarity, this calcium it will stop, because this is the voltage gated calcium channel, and then there will be the rapid repolarization. Repolarization. This is the action potential. See, I told you the adjacent myocardial cells, they are connected via gap junction. Some of the sodium, they will leak from this gap junction, and why this resting membrane potential to the threshold potential. When threshold potential, there is rapid influx of sodium, then calcium is stimulated, then potassium is also stimulated. There is influx of calcium, influx of potassium. Then this cascade is going on. Okay. So this is the action potential. See. First, what was there? What's the resting membrane potential of heart? Tell us. What is the resting membrane potential? Minus 90 milli volt. This is the minus 90 milli volt. Okay. This is the resting membrane potential. Then there was the rapid depolarization. What do you mean by depolarization? Mechanically. Depolarization means contraction. Depolarization can lead to contraction, and repolarization it will lead to relaxation. Okay. So there is the rapid depolarization. Then isoelectric phase because of efflux and influx. Okay. Then because potassium channel is faster, it will tend to gain negative polarity. Then it will stop calcium channel. So there is rapid repolarization. So this is the phase 0, phase 1, phase 2, phase 3, phase 4. Phase 0 is rapid depolarization and rapid influx of sodium. Phase 1 is stimulation of calcium channel. Then phase 2, efflux and influx of calcium and maintenance of charge. No net gain or net loss of charge. Maintaining isoelectrical phase. That's a flight phase. Phase 3 is rapid repolarization and phase 4 is again resting membrane potential. See, the anti-arrhythmic drugs. Anti-arrhythmic drugs. How many classes are anti-arrhythmic drugs? 4 classes. Which one is first class? Tell me. Firstly, which one is first class? 50 year, 4th year. How many types of anti-arrhythmic drugs are there? Huh? There are 4 categories. First one category is the sodium channel blocker. It will work here, like example quinidine, procainamide, okay, lidocaine, phenytoin. It will work on here. Okay. Second is beta blocker. Then third one is potassium channel blocker. Here, what is the example of potassium channel blockers? Which can work on here. What is the example? Which is the most used anti-arrhythmic drugs? That is amiodarone, which is potassium channel blocker. That is a broad spectrum anti-arrhythmic drugs. Then calcium channel blocker, verapamil, daltiazine, these are there. So these drugs work on the action potential. Okay. So till now, what we learn first the electrophysiology of heart. In that we will see, we learn the conduction system of heart, and then action potential, how the action potential is generated. Then second rules, very important. These rules are very important. See, this is a myocardial cell. This is a myocardial cell, and this is the galvanometer. This is the positive terminal. This is the negative terminal of galvanometer. Okay. When there is no current inside the myocardial cell, the deflection will be no deflection. No current, no deflection. No deflection. Okay. First rule, number first. Rule number second. See, when it is appropriate stimulus from the acid node, it will depolarize the tissues like this. Okay. Sorry, like this, and the direction of the current is like this. Okay, from positive terminal to negative terminal. Okay, or from negative terminal to positive. See, when is the direction of positive current towards the positive end of the electrode, deflection is positive. Deflection is positive. So the galvanometer is going to deflect in positive side. Third rule is when the positive current is moving towards the negative terminal of the electrode, deflection is negative. Fourth rule is negative current towards negative terminal of electrode, deflection will be positive. Then negative current towards the negative positive terminal, deflection will be negative. Okay. Then sixth rule. See, if the mitochondrial cell is completely depolarized or completely repolarized, there is no deflection. See, completely depolarized or repolarized, there is no deflection. There is no deflection. How many rules are there? First one is no current, no deflection. Direction of current, positive current towards positive terminal, deflection positive. Second, third, positive to negative, deflection will be negative. Fourth one, negative towards negative terminal of electrode, deflection is positive. Negative to positive, deflection is negative. Completely depolarized or repolarized, deflection is no deflection. Okay. So another rule we have, I told you before a while that which part of what is first conductor? Ventricle. Okay. So when the current is passing through the ventricle, okay, and we apply the galvanometer on it. Do you know what is galvanometer? In physics, you may have studied this too. Yeah, which can detect the electrical signal. Okay, it's a device. Okay. So we will apply the galvanometer on it. Since I told you the mitochondrial cell which is in the ventricle is fast conducting and produces strong current, the deflection will be rapid because it's a fast conductor, and the deflection will be greater in magnitude because it produces strong current. Okay, rule number 1. Rule number 2. Then I told you the atria it's not as compared to ventricle, it's not fast and produces slow. Means so it's going to induce deflection, that is gradual deflection, because it's producing small current and it's not fast conductor as compared to ventricle. So it's going to induce gradual deflection. The needle will deflect like this. Then come mild. Okay. The third one is I told you that AV node, when current is passed through AV node, it is that much slow conductor. Even the ECG machine cannot pick the current flowing through the AV node. So we can say the AV node is electrically silent. There is no, when current passes through it, there is no deflection. Okay. And last rule. See, the tissue which will depolarize last will repolarize first. See, first this tissue will, these cells will get depolarized. Then later on, the outer cells will get depolarized because this is moving in this direction. Okay, this is moving in this direction. The rule is the tissue which will depolarize later on will repolarize first. So how we so the repolarization will be like this. Okay, like these. These are the rules which we have to keep in mind. Okay. Now I will tell you the vectors. All the vectors are found in the out. Okay. Okay. See. Here is SN node. Okay. Here is SN node. When SN node fires for the conic emitter. Okay. When SN node fires, it will lead to the depolarization of cells like this. Okay. Then these cells will depolarize adjacent cells like this. Like this. Then these like this. Okay. See, these are going to produce electrical current. Electrical current is which quantity? Vector or scalar quantity? Vector quantity. And we can represent the vector quantity by direction. Okay, vectors. So these are going to make vectors, small vectors carrying positive charge in its head toward the apex downwards of the heart. Okay. So they will produce small vectors. We will take the summation of the vectors, and these vectors can be represented by a single vector moving towards downward, like this. Okay. Carrying positive charge in its head towards the apex of the heart downwards. Okay. So this is the first electrical event. This is the first electrical event. Then the second. Then second here is AV node. Here is AV node. I told you that this acts as an insulator. When the electrical signals reach there, they will die out because this is insulator. The only gateway is AV node. So AV node, I told you, is a very slow conductor, very slow. So there is no formation of vector. There is no formation of vector. Then third one is see, after AV node, what is the conduction system? Bundle of phase. See, this is the bundle of phase, represented by pink color. Okay, this is the bundle of phase, and then Purkinje fibers. Okay, these act as electrical wires. This bundle of phase and Purkinje fibers, they act as wires. As same the wire is C, the wire which is surrounded by insulator. Okay, same on the right side. Sorry, left side, it is surrounded by an insulator, fibrous tissue. On the right side, okay? Okay, like this. And on the, this is left side, okay? This is left side. On the right side, there acts some gaps are there. Gaps are there, okay? Okay. Here I will draw another heart. So it will be good. Okay. See, this is the ventricle, okay? On the ventricle tissue. This is the ventricle tissue. This is the bundle of this. This is the fibrous. This is the fibrous tissue which acts as the insulator, but there are some gaps, okay? And on the right side there is no gap. There is no gap junction, okay? So the first tissue, the ventricular depolarization, it will occur in 3 stages. First, septal depolarization, then major ventricular depolarization, then the basic depolarization. See, this is the AV node, here is the AV node. When current passes from AV node to ventricle, from bundle of his, these bundle of his, it will carry the current. Some of the current, see, it will lead through via this gap junction. Why this gap junction? So they will depolarize the septum, okay, like this, okay. So we will deploy first the myocardial cell, second, then the epicenter, then the. So it's going from the vector here. So the septal depolarization is going to make a vector in this direction. You are understanding. It's going to make the direction upwards, carrying positive charge. Because see, these are the direction of the septal depolarization is from bottom to upward. From bottom to upward. So here will be the another vector is this is the septal depolarization. Okay, carrying positive charge in its head towards the upward area. Then see, then there will be the major ventricular depolarization like this. Okay, this is the Purkinje fiber. Okay, this will stimulate rapidly the major ventricular tissue like this. Okay, first it will stimulate first cell, then second cell, then second cell, then third cell. Going to the direction is like this, and in the same right side, the direction is like this. See, these are direction like towards opposite side. So these vectors can be represented by a single vector. When we take the summation of the vector, these two vectors can be represented by a single vector carrying positive charge towards its head, towards downward. These vectors can be represented by a single vector carrying positive charge towards its head, towards downward. This is the third vector. This is the third vector. The fourth vector is base vector. This is going to form like this. Okay, carrying positive charge. Because see, this bundle of this. Okay, then it's going to later on stimulate the basal part like this. Okay, first it will stimulate like this. So the direction of current is like this, and in this direction also like this. So we will take the summation. It can be represented by a single vector, which I have shown this. Okay, so these are the vectors. These are the elliptical events which occurs during one cardiac cycle. Now we will do one scientific work. So now this is heart. Okay, so this was the first vector carrying positive charge, and then this was the second vector carrying positive charge upwards. Okay, then third vector. This is the septal depolarization. This is the major ventricular depolarization. Then the third one is basal depolarization, carrying positive charge upwards. This is downward. Septal is upward. Major ventricle is downward, and the basal is again upward. Okay. Now here is the man. He is not happy because he is having some heart problem. So we will apply galvanometer on this person. This is the galvanometer. Okay. The positive terminal we will apply. This is the positive terminal. Okay. This is the positive terminal. This is negative terminal. Positive terminal we will apply to which side is this? Left side. Left side. Okay. And negative electrode we will apply on the right arm. This is the negative electrode. Okay. This is negative electrode. So here, this is the basic ECG machine. Basic ECG machine. Okay. And here we are going to piece of paper. This is the wooden cord. And this wooden cord, the motor is applied on it. So this wooden cord, it can be rotated clockwise like this direction. Okay, and this is the paper roll. The paper roll is moving in which direction? This direction. Okay, and this is the ECG needle. Okay, ECG needle. When we switch on the motor, okay, the paper it will come to this side. Okay, and if there is no electrical signals during the repolarization, there will be no deflection. So straight line. Okay, straight line. During first vector, during first event, that's the first electrical event in the area, carrying positive charge in it is towards positive electrode. Deflection will be positive, because this is atrial depolarization. This is slow and not stronger current. So this the deflection will be positive but gradual and slow, like this. Then it will come back. Okay, it will come back. So current then the current passes through AV node. AV node, I told you, galvanic is not going to detect the current in AV node. So deflection, there will be no deflection, straight line. This is going to make the PV. Okay. So there is no deflection. Okay, when current is passing through the AV node. Okay. When the current reaches from AV node to ventricle, which part will stimulate first? Ventricle. Ventricle septal. Okay, septal depolarization. The septal depolarization carries positive charge towards positive, negative electrode. We have applied electrode on the right side of the arm, and this ventricular depolarization factor, it carries positive charge towards negative electrode. Deflection will be negative. And this is a ventricular factor. It will be rapid and fast. It will be rapid like this. Because septal is a small part. Okay, so it's going to produce small current, but rapid factor. Okay, rapid current. So this can be represented by Q. Okay, then major ventricular depolarization carrying positive charge toward positive electrode, and the myocardial is bigger inside, produce strong current, and it's a fast conductor. Deflection is fast and bigger, like this. Okay, so which wave is this? R wave. Then the needle will come to its position. Okay, then later on, which part will get stimulated? Basal ventricles. The basal ventricles form the ventricles which carry positive charge towards negative electrode. So deflection will be negative, because it's a ventricle, it's a rapid. Okay, like this. Which wave is this? R wave. Sorry. S wave. This is S wave. So when there is, after septal, it depolarizes, major ventricular get depolarized, basal ventricle it get depolarized. There is a complete depolarization. When there is complete depolarization, there is no deflection. So the needle will have a straight line. Okay. After last of all, I told you the part which will depolarize last will repolarize first. Repolarizing negativity. Okay, negativity like this. Okay. So these negative currents are towards negative terminal, and so deflection will be positive. And see, repolarization is slow. It's a gradual as compared to depolarization. So there will be a gradual and slow deflection in the galvanometer. And which wave is this? P wave. Okay. So what is P wave? Tell quickly. P wave. What's P wave? Loudly. Tell me which way you know. Tell. P wave represents Q wave septal. S R wave. R wave.
Major.
Tell loudly. Tell everyone. Tell. R wave. R wave.
Major ventricle.
Major ventricular depolarization. Then S wave.
Basal ventricle.
Yes.
Basal ventricular. Then T wave. Ventricular repolarization. Okay. See, when there is depolarization, there is repolarization. Depolarization is contraction and repolarization is relaxation. See, when atria contracts, then atria relaxes. But there is no atrial repolarization. Do you saw any atrial repolarization in ECG pattern? No, because at that time when the atria gets repolarized, at that time ventricle is depolarized, and ventricle is a big tissue, and first it's going to massage the atrial repolarization. Okay, so this is how the ECG pattern is formed. Okay, now we have intervals. Then the which interval is this? PQ interval. So for it is actually referred as PR. Which interval is this? Okay. Then QR, QS, QT interval, QT interval. Okay. So these intervals you are going to read in the next station. Till that my job is finished. Okay. Thank you. Any question? Any confusion? Any question? Any intern is there? Intern. Fifth year? Yeah, complete. Okay.